And away we go. So welcome today to today's session. My name is Josh Brothheim. I am the training manager at Sumo Logic. And what we're going to be doing today is going over, well, as the title says, and hopefully you're aware of, AWS Observability, specifically using tracing and root cause explorer within Sumo Logic. So we're going to be looking at two features within Sumo Logic that assist with observability. And we're going to do some hands-on labs with those as well. So we'll get some on the keyboard time today. If there's any questions, go ahead and put them in the chat. We're together for about an hour, which is great. Yeah, let's keep going here. So an agenda for today, we'll be sticking to this pretty closely. Going to do the intro, which we're doing right now. Going to talk about end-to-end observability, kind of do some definition, some level setting, make sure we're all on the same page as we have this conversation. Then we're going to talk about Sumo Logic and AWS observability. So how do they tie together? How does one help the other? And then, as mentioned, looking at that root cause explorer, going to be able to find and solve and prevent failures with it. And then look at tracing as another tool or feature of Sumo Logic to help you with that observability. And then next steps. So that's the plan for today. Come on, slides. Here we go. So starting off with Sumo Logic, who are we? What do we do? You may know, hopefully you do, but if you don't, that's perfectly fine. I just want to kind of highlight who we are, what we do. So Sumo Logic offers continuous intelligence for all your applications. In the real-time analytics layer, when we look at analytics, they're essentially divided into four main areas. Operational analytics. Are your systems up and running? What is your MTTI and MTTR, those mean time to identify and resolve, those metrics that are more and more important every day, really. Other system health concerns certainly can be garnered or gathered through the operational analytics kind of view. Security analytics, helping you identify who is using root access. Is a person logging in from multiple locations simultaneously? And other security related questions. The business analytics side of things is great for determining what pages are people frequently viewing on your website. What are they ordering? If you ran a marketing campaign, was it successful? And then global insights, as the name sort of implies, it's going to show you how you're doing compared to other companies, typically focused on a security area, but can certainly be expanded to other areas of the business. With the cloud native platform in the middle here, it's important to note, hopefully you know, but if not, of course, that's why I'm telling you. Sumo Logic was born in the cloud. It runs in the cloud, and as such, our applications are multi-tenant. Information is not shared between the different tenants. It's very secure. We have advanced analytics and machine learning in our application. We are elastic. Since we're in the cloud, we have the ability to scale the environment based on demand. We support APIs so that companies can incorporate Sumo Logic into other products and provide the highest quality out of the box security. Our security compliances, as you see here on the right-hand side of the screen, include SOC 2, PCI, HIPAA, and the one we're not missing on here, I actually apologize, this is an older slide, is our FedRAMP. So we are FedRAMP approved and authorized. I can't remember the exact phrasing of it, but I should have this on the slide because that was a big deal getting that FedRAMP. We got that, I guess, earlier this year. And then finally, the full stack integration. As we know, and as you know, customer needs are varied, but specific as well. And so we support on-prem infrastructure, bare metal, servers in the closet. We support IaaS, PaaS, cloud, all those platform as a service, infrastructure as a service, the AWS services, of course. The apps, we won't look at apps today. I'm trying to remember if we will or not. No, I don't believe we do. But what we have is a really cool feature called apps. And what they allow you to do is overlay queries and dashboards that somebody as Sumo Logic has created that we think or know will be valuable to our data source that you're looking at. And this overlay allows you the ability to view this content without creating queries. It's a great feature of Sumo, and usually can solve or exceed 85% of your immediate query and analytic needs. Let's see what else about here. That's about it. Oh, I guess the SaaS software as a service, certainly supported for that. And then integration with third-party apps. So you can integrate with services or, services, I guess, such as Slack or ServiceNow or Discord, using things like webhooks to integrate those that communication, which can be a great help into communicating out to your users. But now let's go ahead and get a little bit deeper into observability. Now that you know a little bit about Sumo, Now let's start to talk about end-to-end observability within Sumo. And as we do that, I want to first kind of separate the terms observability and monitoring. Both terms are used frequently. Sumo supports both features, but I did want to kind of describe the difference because some people might think of one as the other. And like I said, just to kind of level set. So when we're talking about observability and monitoring, like I said, a lot of people equate the two, and they're certainly related, of course. But as we dig into them, it's not just about seeing when something goes wrong, but what's causing it, what areas it's impacting, and how we correct it before it impacts more customers and more parts of the application. So how is observability different from monitoring? Monitoring is about telling you the state of a system by looking at parts that have been configured to be monitored. If a part of the system isn't monitored or hasn't been configured to be monitored, then it won't be monitored. And as a result, we'll really have no idea what's happening there. Observability goes deeper or goes beyond monitoring by bringing together logs, metrics, and traces to give us a broader view and a deeper context. So wanted to just set those definitions in place. They might be common, but like I said, just to kind of level set, make sure we're on the same page. Couple diagrams here that I hope will be helpful. They're kind of busy, but they are also quite descriptive as well. What we're trying to show here is one aspect to achieve end-to-end reliability is having a unified observability platform. What does that mean? Well, starting on the left-hand side of the screen here, what it means is it's required to get all bits of data telemetry to perform the tasks that teams who are in charge of reliability, such as DevOps, DevSecOps, from each and every layer that affects the application. Essentially, your data could be coming from your hosts, your servers, your application components like your database, security, microservice infrastructure, cloud infrastructure, and many other places that you might even beyond that have CI/CD pipelines, CDN services, load balancers. You have a lot of data. And it's required to have all relevant data, such as previously mentioned metrics, logs, traces, metadata, in your Sumo Logic platform for visibility. This allows you to monitor alerts, giving you the what's happening information, as we see in step one here. Once we've monitored, then we can start to diagnose the trace spans to figure out where it's coming from. And then in step three, we can use the troubleshooting of root cause analysis to start to determine, do we have too many alerts? What's going on? Why is it going on? And today we're going to primarily focus on step 2 and step 3 here. And we're going to do some lab activities towards those shortly. Taking this diagram and kind of flipping it, no, I don't know that we're really flipping it, but yeah, I guess we're flipping it on its side. What I want to talk about in this slide is the observability value of multiple teams and use cases. Essentially, how can various people in your organization benefit from Sumo Logic or benefit from observability? Let's keep Sumo out of it even, from observability. Well, here are some personas and team names or groupings and how they can get value from observability. So for example, the SDRs or the DevOps people, those individuals that are responsible for monitoring the health of the application, they need observability. The reason they do is because this is going to help them quickly monitor, diagnose, and troubleshoot application health issues. Observability is going to help the software engineer on the team and provide visibility into the software pipeline. By collecting information about the software pipeline and identifying issues within or about the software delivery process, teams can improve the quality as well as the delivery of their application. And then finally, for DevSecOps folks, excuse me, a bit of a tongue twister, those security-minded individuals, Sumo, or once again, observability, is going to ensure the correct security posture of their applications. What's unique about the Sumo Logic observability solution is it addresses the needs of all these teams and personas in one integrated platform. Now we got another slide here that shows similar information, but takes the different visual on it. What we're showing here, or attempting to show here, is kind of an iceberg slide. In that, observability, as it says on the left-hand side of the screen correctly, observability requires more data and richer analytics as you go from alert to the problem resolution. So at the top of this iceberg, the portion that's sticking out is the what that's being monitored via monitoring. Now, utilizing monitoring is going to be helpful, but it's only going to really show us that what is going on, not where or why or how. And those pieces are, I don't know if they're more important, but they're as important in helping you detective work your way into what's going on or what isn't going on. And as you do, as you want to get deeper to determine the wheres, the whys, and the hows, more data is going to be needed. And that's what we're trying to show with this slide. As a result, once you have more data, you're going to need more sophisticated analytics. If you're pumping a lot of data into the system, I don't want to say basic analytics won't cover it, but you need more advanced features, and that Sumo can assist with that. All right. Gonna just kind of pause here. Any questions? You guys have been pretty quiet, which is fine. If there's any questions, go ahead and shout, but otherwise I'll keep rolling here. So now we're going to talk about Sumo Logic and AWS Observability Solution. How does one help the other? Or do they? And of course they do. That's why you're here, to learn how they do. So let's go ahead and start to dig in here. Now, what we found, and I think you will probably agree with this as well, is many of our customers, there we go, get this rolling here. Here we go, there it's loading now. So AWS encourages the use of separate AWS accounts to help manage costs, as well as give teams independent administrative control. Additionally, different accounts often have different settings across regions depending on the needs of your specific app. Once you're in a certain account and region, then there's a multitude of services that customers can use to run their apps within each service. EC2, many of them, of course. And what we found as what adds complexity is that with the problem here is these complex hierarchies often leave vast data silos where it can be difficult to acquire a clear picture of overall AWS service health across regions and accounts. So what we found, and like I said, you probably will agree with or can relate to, is the fact that our customers and AWS customers in general have multiple accounts. They also have multiple regions. So you might have an account for your production data. You might have an account for your development data. You might have an account for your QA data. It might be structured differently, but you might have multiple accounts. You might have multiple regions set up. You might have production for US East. For APAC, you have your QA data. You might have production and QA data in APAC, having two different accounts. There's a lot of complexity that goes into here, into separating these out. Very few customers have one account in one region. If you do, great. If you don't, that's great too. Sumo can help you with it either way. But what we're trying to help here with specifically is the challenge of multiple accounts across multiple regions, understanding what's going on in those environments without having, as you see here, 5 different tabs that you have to sort through and click on and dig into. We want to give more of a unified pane of glass, if you will. And we're going to look at that shortly. Within, and I alluded to it, within those different accounts and those different regions, there's many different services. So you might be using production in APAC and using EC2, and in your I don't know, in your Europe QA environment, you might be using RDS. And so how can you start to look at those different things or different environments, once again, through that kind of single pane of glass? That challenge is that visibility, and how can we help with that? Well, let's start to see. And before we show you how we can help with that, continuing with this thread, troubleshooting is complex. On the left-hand side of the screen, what we're trying to show here is the idea that very simply, troubleshooting is complex. You might have your Lambdas, you might have your EC2s, they're all coming into one another. How do you start to view these different silos in AWS accounts? And this is what, on the right-hand side of the screen, is the environment that you might be more familiar with, where you have your instances and all these different environments and different regions and so on and so forth. And once again, how do we solve for that? And so from complexity and chaos on the left-hand side of the screen is going to be coming clarity and root cause. And so we're going to start to take a look at these dashboards, these views of the data that are more simple, but in a beneficial, more simple way, not leaving things out. So let's go ahead and, one last quote here I have that I find kind of, I don't know if it's funny or not, but relevant certainly. What it says here is we've replaced our monolith with microservices so that every outage could be more like a murder mystery. And utilizing observability through Sumo Logic, or just observability, period, what you can start to do is, as the quote is alluding to, your data and your logs are going to appear like a murder mystery, in that you're no longer going to just see that something happened. You're now going to see that something happened. And if you remember the board game Clue, I'll use that as a reference, that Professor Mustard was in the observatory with the wrench. And so you're going to start to get all that information, and you're going to be able to start to read, if you will, those logs, those environments, to see what's going on or not going on, depending on as the case may be. So I thought this quote was kind of humorous. My humor, I guess, nerd humor. All right. So now we're going to start to talk about RCE, or Root Cause Explorer. And actually, let's see. I'm just trying to think if I want to flip this around a little bit. Yeah, let me show Root Cause Explorer. Let me do a little tour, and then we'll go in and look at it together. And this is the demo I'm about to show you. So let me go ahead and just dive in here. And apologize, I got logged out here. So just 1 second. Questions, feel free to ask. Kind of tap dancing here. And now we're in Sumo Logic. Hopefully you know what Sumo Logic looks like. If you don't, that's perfectly fine as well. We're going to get logged in together in about 10 minutes, not even that long. So what I wanted to show was Root Cause Explorer, what it is, why it's helpful, and how it works. So I'm going to go ahead and just open it up here. So I'm going to go ahead and go into Root Cause. And I'm crossing my fingers. I didn't test earlier. I'm kind of hoping my data is here. Oh, wow, there's lots of data. So what we're seeing in here, and let's just take it from here. Let's take it, and then we'll drill down. What I'm seeing in Root Cause Explorer is, let's go over the graph here. What I'm seeing on the x-axis is time. So over the past 3 hours, I'm seeing events that have been flagged as events of interest by the system. On the y-axis, what I'm seeing is what we call drift. And what drift is essentially deviation from the norm. And so what I'm starting to see here as I mouse over some of these items, let me do so and pause here, is I see information about this event of interest. So for example, the one that I've moused over right now, the system has determined that this deployment load is a little abnormal. It's telling me specifically that this entity is related to Workday training, which is, some internal categorization, which is helpful. It's telling me where this is happening at the SE demo. It's telling me the specific metric that's in play here, specifically the CPU usage. It's telling me the stats about the CPU usage. It's telling me the drift. It's telling me how that it's been deviating from the norm and for how long. And as I mouse over other ones, I see more information. So for example, here we see deployment load is spiking, the CPU usage. More CPU usage, a lot more CPU usage. This is a training environment, so this data kind of replicates itself. Let's see, what can we do in here? We can add filters to start to clean up the data. Right now, we're looking at all of the data that we're pumping into Sumo Logic. AWS data, Kubernetes data, some application service data. What we can do is we can start to turn off some of these items so that we're only viewing data that might be relevant to what we're interested in. So for example, let's say we only were interested in AWS data, because that's really what we need. Well, that's our job focus. We can start to turn off some of these filters. And now what we're starting to see here is these events of interest, but a little more segregated, and starting to provide us in a time frame what has been going on or not going on. So for example, that description was pretty lousy. So let's go ahead and look at this one. What we see here, and actually we can start to clean this up even more, is we can look at different of the accounts. So as I mentioned, you might have production, you might have development, you might have QA. We can say, just show me production data. If I'm not interested in development data, everything's working fine in the dev environment, I don't really care about it. So in this case, just show me production data. And now what I'm starting to see here, and I can get more granular, I can look at a specific region if I want, I can look at a specific namespace. I'm not going to, because I don't need to get that granular. But what I can start to see here are events that took place and hopefully some correlation between what happened. So what I see here is, and we're actually going to look at this, I guess we can still look at this example together, is I see a ELB app error. I see it happened at about 40 minutes ago. And I see specifically the ELB 5XX count is high, or out of norm. It's high. It's out of the norm, meaning it's high. I can then go ahead and just look back previously in time and start to see other events that the system has correlated or combined and is letting me know they may be related. They may not be, but the system's letting me know that there's some relation. So here I see this 500 errors that have occurred in the ELB app. Well, if I go just a little bit further back in time, prior to the ELB app error, I see a bottleneck here related to CPU load average. Now, did the CPU load average bottleneck cause the ELB app errors? Maybe, maybe not. We're going to kind of investigate that as a team shortly, so I don't want to reveal it. But the system is starting to let us know that there might be some correlation here. There might be some connection. Prior to this bottleneck of the CPU load average, there was a DynamoDB read throttle events error, or not necessarily an error, but an outlier, and that's outside the norm. Now, did this DynamoDB bottleneck result in the bottleneck in the load average that then resulted in the 500 errors? Once again, maybe, maybe not, but we're going to start to dig into that shortly to see if it did or didn't. Let's see, what else do we see on here? As we choose these event of interest, or EOIs as we call them, events of interest, when we click on them, we also see some information on the right-hand side of the screen. And what we see here is, depending on what we're choosing, but in this case, since we're looking at metrics, we actually see the metric graph displayed. And what this graph is showing us is the ELB 500 count for today, for about the past hour, actually I guess the past 3 hours, the ELB count for yesterday, and the ELB count for 7 days ago. And what this is showing us is the green and the light blue represent yesterday as well as 7 days ago. And what we're seeing here is that those were, while they did peak and valley here, they certainly go up and down, the green and the light blue. And I can get rid of that dark blue to illustrate it better. I thought I could turn that off, I guess not. The green and the light blue, while they go up and down, they're at least fairly consistent in their range. But what we see here is this dark blue representing the 500 count had just happened about an hour ago. It spiked and then went down. That's abnormal. That's not what has taken place yesterday or 7 days ago. And so we're getting some visual confirmation, that this is not quite right. And once again, don't know exactly what caused it, although we're starting to see some of the root cause, hence the name. But we're starting to get some indication of what might have gone wrong. So what I want to do now, I think I want to have us jump in here. Let me close that. Let me get back to the demo or the slides. Yeah, here we go. Okay. So what I want us to do now is, as a team, or not as a team, as a group, do some of this lab exercises. So what we're going to do is place you in the scenario that you are new employees of a company called Travelogic. You may have seen the Travelogic demo before. You may not have. Either way is fine. We use Travelogic as a use case. And what it is a production environment where users can go and book airfare and hotels. So when you've gone on vacation and you use those type of sites, imagine Travelogic is one of those sites. And it's a production environment up and running. And let me go ahead and continue with this, but there's a good question that I'll answer just while we get into this exercise. So here's our scenario for today, or really for the next 10 minutes. There's been an AWS incident within Travelogic. You, a DevOps specialist on your first day, are supporting mission critical apps on AWS that correspond to ELBs, Host EC2, and DynamoDB. And so those are kind of your area of expertise, if you will, or should be your area of expertise as a new hire. And what we're hearing is the end users are experiencing an outage in the application with the 500 error, and we started to look at that 500 error in the US East 1 area in the last 24 hours. So over the last 24 hours in the US East 1, there's been a lot of 500 errors. As it says, being a DevOps specialist, our challenge is to troubleshoot and rapidly isolate the root cause. So how do we go ahead and start to determine, one, if anything is going wrong, and if it is, what caused it? Once again, root cause explorer. So what we're going to do is we're going to log into the system today. The account we're going to use, the URL first, priority, is service.sumologic.com, which hopefully you're aware of. If you're not, that's perfectly fine, but that's where you go to log into Sumo. The credentials we're going to use for today are going to be training plus analyst, and you're going to choose a 3-digit number. So maybe you want to be training plus analyst 007 at sumologic.com. Maybe you want to be training plus analyst 391 at sumologic.com. Pick a 3-digit number. And then go ahead and utilize the password of Sumo Summer 21 exclamation point. So capital SUMO, capital SUMMER, 21 exclamation point. So go ahead and log in. I'll give everybody a few moments to do so. And actually, let me go ahead and put those credentials in the chat as well to make it easier for you. Where's the chat? Okay, there's the chat. Once you get in, if you wouldn't mind just saying in, just so I can verify somebody's logged in and those credentials work. They should, of course, but just to verify. While you're logging in, excuse me, I got a very good question from Doug. The question was, how does Sumo Logic get access to the AWS? Very good question. What the process is here, and we won't go through it in too much detail, but what is being utilized is what we call a collector. Within Sumo Logic, we utilize the idea of collectors, and what they are is essentially little applications that can either be run on a device like a little application, or can be run in the cloud virtually. I'm going to leave it a little vague for that. But basically what they do is they get the data and bring it into Sumo Logic. Let me see, just while we're waiting here, I believe I have a better article that will help with that explanation of bringing the data in. Where is it? Let's see if I can just find it quickly. If not, it's in our help article, very thoroughly documented. Yeah, of course, it's not going to pop out right now. Let's see, do I have a bookmark real fast? I'll include a link in a few moments about getting that data in. It's a great question, of course, Doug. Just we don't cover it much in here. We're kind of assuming the data has arrived already. Our admin class covers it in more detail. So like I said, I'll try and find a help article just in a moment. But now that we're all logged in, or hopefully all logged in right now, let's go ahead and start to dig in here. When you first logged in, you should be brought to a page that looks pretty similar to this. This is the home page. Like I said earlier, hopefully you've seen this page, but if you haven't, that's fine. Like any other home page, the idea is just to get you up and running really as quickly as possible. Now, what I want to do first before we go into Root Cause Explorer, this is something I actually should have shown first, I don't know why I didn't, is I actually want to show the observability taking place. So what I want to do here is, let's see, do I have any instructions here? Yeah, I do. Let me copy these in to the chat, and then let's go ahead and do them together. So what I want to do, and I'm crossing my fingers that there's data in here, is I want to go to New, and I want to go to the Explore option. And I can either do that by clicking Explore or going to New and Explore. Same difference. You'll find in Sumo Logic, if you don't know already, many ways to do the same thing, intentionally so. So I'm going to go to Explore. And what I'm presented with, and crossing my fingers you're presented with, is Explore by AWS Observability. If it shows Explore by something else, go ahead and modify it by clicking on this down arrow to AWS Observability. But what we're starting to see now is all the data that's been brought in, however it got in, magically we'll call for now, and it's being presented to me through Sumo Logic and giving me insight into my environment. So for example, I can look at my dev environment, I can look at my prod, my stage, testing, training too, just other environments I've created or brought in or imported. And so looking at, let's just, the first one first, I see for dev, for example, I see activity locations. So this is now showing me over the last 24 hours, where in the world people, or I guess not necessarily people anymore, computers or accounts have logged in to the dev account. Well, this right away might be helpful. If I have no users, no business in APAC and people are logging in from Australia, this might be concerning. Probably not, but this is starting to give us that insight, that the ability to observe what's going on. I see AWS resource activity on the right-hand side here. So I see all the different not products, features or services, that's a better word, in AWS. And I see the creation of them, the deletion of them, the updating of them. And so, if I'm not expecting any deletions in EC2 and I have some, this might be concerning. We can keep going down in here, and we're going to go more specific to towards our use case, but just in this dashboard, we see, just keep going here. ALB errors. We're starting to get the honeycomb view, which is really kind of helpful to show us that some regions and namespaces are having errors and some are not. Just keep scrolling in here. Feel free to keep looking, but we're starting to get all this different detail. We can go deeper into these by clicking on I guess it would be the account. So for example, in the dev account, we might have multiple regions. Now we can go specifically and just look at US East 2. If US East 1 is up and running or is not our concern, now we're just looking at US East 2. And now we're seeing those incoming activity locations, those resource activities, et cetera, et cetera. This is more of a higher overview of the region information. We can get more granular, and we will do so, but we'll do it right now as well, to start to look at specific services. So for example, let's say we wanted to look at Lambda. I click on Lambda, and now Sumo Logic is showing me all these different things about Lambda usage. Now, in some cases, we have no data to display. Once again, this is a test environment, so there might just not be data to display, but it's starting to show us what data is and what isn't. And here we're starting to see things like most frequent function operations. Once again, may be helpful to you, may not, but it's starting to give you that insight. So what I want to do here is I want to go back to our scenario and start to see, or see if we can see if we can observe issues going on in production with the US East 1 related to 500 errors. So what I'm going to do is I'm going to go into Sumo, and I'm going to choose the production account, because we want to look at prod data. There's a production environment. I don't care about dev data right now, so I'm going to click on prod. Now, in addition, I only care about US East 1 because that's my responsibility. Let's say US East 2 is Bob's responsibility. He takes care of that, but US East 1 is mine. That seems to be where there's errors. Let's go ahead and look at US East 1. So what I'm looking at here is US East 1. And once again, all the different things that are happening with it, good and bad. Here we're starting to see some errors, more errors, but we're starting to dig into these different environments. Now what I want to do is I want to go back to the root cause explorer. So I want to go to new and root cause. And wait for it to load. And now what I want to do is I want to start to filter my data in a similar manner, because I want to look specifically at the AWS data. I don't want Kubernetes or application service data. It's just not relevant to this exercise. And so I'm going to go ahead and click account prod. I'm going to click region US East 1. And what I'm going to do here, let me see. This is more of just a data thing. All right, so actually, sorry. So you can actually keep the last 3 hours. The data we have in here should work. Let's see if it does. So I was starting to show this earlier, but what we see now is we see for a 3-hour period, we should just see 3 points if we're using prod and US East 1. And what we're seeing here is, once again, in that time range or duration. If we go furthest to the right, we see an actual error. So the system has identified this as an error. And what it's done is it started to use, once again, that correlation, that causation, those advanced analytics, that special sauce, those secret features to start to provide context to other events. And so what it's saying here is this bottleneck occurred prior to this ELB error. There we go. Related to CPU load average. Prior to that was a DynamoDB bottleneck. And as I showed earlier, we see that spike here that's indicating that this is an abnormality. Something happened about an hour ago, maybe an hour and a half ago, that is weird or out of the ordinary. So what I want to do here is I want to, and I'm crossing my fingers here, is I want to go back into the Explorer and now dig into these areas of the DynamoDB to start to see if I can see some information in the observability view. So I'm going to go back to Explore. I'm going to go back to US East 1. And what I'm going to do here is look at, let me just make sure it's here, fingers crossed. We're going to go to the AWS application ELB, the namespace. Because if you remember, that is part of one of our responsibilities as a employee is to monitor that. And when I go to that ELB namespace, it's actually application ELB, but ALB, we see here 500 errors codes. And if you remember, that's something that we're interested in, is looking at those 500 codes. But more importantly, trying to figure out what caused them. And what we see down here, if we scroll a little bit, is we see 500 by load balancer. And what this is starting to show us is this guy right here, about an hour ago, or an hour and a half ago, this spiked. So what we're seeing here is, and I can actually turn off the other one. Actually, I just want to keep that one. What I see here is this Sumo Logic service. It spiked with 500 errors. And so we want to start to dig in here and start to figure out what caused these errors. The root cause explorer is showing us that we got the errors, the ELB errors, and then bottleneck errors from CPU load average, and also a DynamoDB bottleneck, but we still don't know what caused that. We see these are related to that, but once again, cause. And so what we are going to try to do here is figure out the cause. And so I'm going to go ahead and drill into, let's see, this is where my lab is going to break a little bit. Let me see here. Oh, wrong one, not EC2. What I'm trying to show here, let me see if I can get into it. Application ELB. Let me see, DynamoDB. Okay, so here, this is, let me see. So we see our 500 errors related to the ELB, but also DynamoDB is an area that we need to look at. So if we go to DynamoDB, what we see here, we should see here, we should see errors. Let's see. Here we see. So what we see down here are top 10 errors. And what we're starting to see is some reasons of why everything went to crap, for lack of a better phrase. I apologize for the language. What we see here are some validation errors. Basically what happened is our provision throughput write capacity units failed, which that failed. And as a result, that DynamoDB started to have a bottleneck for those read throttle events. Because this bottleneck occurred, the CPU load average started to spike. And then because the CPU load average spiked, as a result, the HTTP ELB 500 count spiked as well, or was increased. And so that's what caused the errors. And so as a result, and using a little bit of jumping around here, but basically the reason that this occurred is due to a incorrect provisioning of throughput. And so that's kind of the big reveal, the big ta-da. And I apologize, I know that was pretty bumpy. The next demo is cleaner. just we get data in here and it wasn't as clean as it should have been. So I apologize for that, but hopefully you at least start to get some feel for how this can be helpful. So let's go back to the slide deck and let's continue here. So what we did there, or what we attempted to do, is identify the error of the spike. And so we looked at the AWS observability, as we see right here. We started to look at that 500 error, so looking at that specific dashboard that had that spike. And then what caused the outage is what we were trying to show here through the root cause explorer is those ELB app errors. And then the actual root cause is, once again, that read throttle events had just spiked due to the inappropriate or incorrect provisioning. And so the system is showing us all that, and we benefited from all that, and we didn't really have to do any querying, any typing. We just kind of pointed and clicked, and the system was able to drill in utilizing that root cause explorer. So in summary, a lot of different things here. RCE embodies 5 concepts. The abnormality of spikes is really a big driver in showing that there's an underlying problem. The context and correlation, that time range is important. The connection between the resources and services, so that one service had something happen, another service had something happen. There's a correlation, a connection between time, and those can be associated. Earlier spikes, something happened a while ago, and as a result, some other things happened or didn't happen, and you can start to see that. And then the log exploration, which we were starting to get into, where we saw the write verify failed. We can start to actually look into the logs to see the specifics of what went wrong. So that's an overview, not the best, but an overview of root cause explorer. And like I said, I do apologize, it was a little bumpy. But this tracing exercise is a little more fun and works a little bit better. So let's dig into here. So in tracing, what we're going to do is we're going to use a different scenario here. What we're going to use is our scenario of Sumo Logic Coffee. You may know Sumo Logic Coffee, you may not. You probably don't because it's not real, but for today, we're going to imagine it's a real company. And like a similar company that has a green logo, you can purchase hot cups of coffee around the world at Sumo Logic Coffee, and delivering a hot, fast cup of coffee is priority number 1. And so that's our business. Now, how are we going to use Sumo? How are we going to use observability? How are we going to use tracing to help us with coffee? Well, let's find out. So here is what a successful order at Sumo Logic Coffee looks like. Certainly from a customer standpoint, you go in, you place your order, you get a cup of coffee and you drink it. That's kind of it. But there's more things going on. The customer places the order first, probably through our fancy Sumo Logic Coffee app, but they place the order. The order is going to go to the barista. The barista is going to start the coffee machine. The machine is going to do a lot of work here. The machine is going to check the bean levels and make sure there's enough beans and then grind those beans. The machine is going to check water levels. And if there's enough water, or when there's enough water, going to add that water and make its magic. And then the coffee is going to be ready for the customer. Now, we don't give free cups of coffee at Sumo Logic Coffee. The customer is going to need to pay for that order. Credit card is going to need to be approved. We are non-cash only credit card transactions for today. And then the customer picks up that order. And in those respects, and alluding to that quote I gave earlier, that murder mystery quote, each step is a microservice. So how can computers and technology help us look at microservices or steps of making coffee? Well, that's what I'm going to show you. What we have here is an example of a successful order at Sumo Logic Coffee. Now, this looks weird, may not, I don't know, but what's going on here is we're seeing a successful order. We're seeing the trace ID, which is just the ID number for this cup of coffee. Remember, we're selling millions of cups of coffee, each day, and so there's going to be a lot of transactions taking place. Hopefully, we see a 200. We're going to use status codes for today. A 2. Oops, sorry, I put myself on mute there. Let me go back for a second. So I was talking about this is a successful order at Sumo Logic Coffee. This is the transaction ID or the trace ID. And then the status code of 200 representing this is a successful order. And what we see with this order is we see here in this first bar, we see the components that take place when an order is requested or ordered. So we see the cash desk, which is responsible for the payment transaction. We see the coffee bar, which is responsible for some other processes that we'll look at in a moment. We see the machine service and so on and so forth. And then what we see down here are the various essentially steps that were utilized to create that cup of coffee. The order, the payment, the preparation. Now what I want to do is start to dig into these traces. So as I mentioned, a status code of a 200 is a successful transaction. But what I want to look at is unsuccessful transactions and start to determine why they were unsuccessful. And I want your help in doing that, or you to help me. So hopefully you're still logged into Sumo Logic. If you're not, please log back in using those credentials that I provided earlier. I'm going to put them in, but I'm going to assume everybody's still in. I guess I shouldn't assume that. I pasted the wrong thing. Okay, there are those credentials again. So go ahead and log in. Like I said, you should be logged in. What I want us to do this time, though, is I want us to click on the New tab and go to Traces. So let me do that. I'm going to go to New, and I'm going to go to Traces. And what you should see is a screen that looks, it looks pretty identical to this. I'll just kind of wait a second just to make sure everybody is caught up. All right, so now we're going to start to do some hands-on exercises here. Let me go ahead and paste this portion in here to the chat as well. This will help you, but help both of us. What I want to do here is, so what we're looking at are traces. And what I want to do first is I want to specifically look at the portion I pasted in the chat. And what it says is service equals the coffee lover for root span. Essentially what I'm doing here is saying, just show me the service of the coffee lover, which is our coffee organization. We have other data in here, just other demo data that's not related to coffee at all. And I just don't really care about it for right now. So I'm going to say, show me essentially just the coffee stuff. When that loads, I start to see the coffee stuff. What I'm going to do here is, yeah, I think I'll do it first. I'll go ahead and click on the status column on the far right to sort those statuses. And what I see from here is I see the trace ID, the transaction ID, essentially. I see when it started. So when did that person order that cup of coffee to kick off the transaction? The duration, this is going to be pretty important. How quickly did the order go from somebody placing the order to somebody receiving the order? We want to get a fast cup of coffee out, so time is going to be relevant. Maybe not to this exact exercise, but certainly we want to know how long or short those deliveries take. The duration breakdown. So what this is showing is a visual of the time it took for each step. And then the number of errors. This is going to be helpful for diagnosing. So what we see in the 200, and feel free to click on one of these 200s, is, as I described earlier, a successful order. Person came in, ordered their cup of coffee, they got it shortly after, life is good. But if we scroll down the statuses, we're going to see some other statuses. Particularly, we're going to see a 402, we're going to see a 502, and we're going to see a 503. There are some 500s. We're going to ignore those for right now, but we're going to look at those 402s, 502s, and 503s. So let's go ahead and start with the 503s. When I go to any of these 503s, doesn't matter which one, I see that there's errors already. So this is already telling me that when there's a 503, something's not quite right with that transaction. And it's happening frequently. I don't know why. I'm about to find out why, but the system's letting me know that. And so what I want to do here is now figure out what a 503 means. So what I'm going to do is, like I said, click on one of these 503s, doesn't really matter which one. And it should open up this view of the traces. The trace view is what we call the screen. Now we had looked at one that was successful and we saw a 200 and we saw a bunch of green. We're now looking at a 503, which is unsuccessful, and we want to figure out why it was unsuccessful. And what we're going to do is we're going to utilize the red lines to show us or lead us to what has gone wrong. The red lines represent errors. Pretty blatant. If you see red, bad, error. What we're going to do here is we're going to drill down to the lowest level to try and figure out what has gone wrong. So here I see the lowest, the red. I'm going to go lower, red, red, red. Here I see red at this blue line. So on the blue, I see a little bit of red, which is telling me there's an error related to this portion, this microservice. As I mouse over it, this microservice is related to the water service, getting water. Okay, that might be relevant. I'm going to go ahead and click on it, though. And what I'm going to see on the right-hand side of the screen is some data. But what I want to do more specifically is look at the logs that are associated with this transaction and try to figure out what this means. So what I'm going to do is I'm going to click on open logs tagged with, I'm going to use the span ID for right now. And what I'm going to see is very clearly what has gone wrong in reverse chronological order. So in message 2 here, I see info received order for water in the amount of 5 milliliters. So somebody placed an order for coffee. The coffee cup required water and 5 milliliters of water. Look what happened. Error, not enough water. So what this means is very simply, there was not enough water to fulfill this request. If we go back to our traces, if we were to look at any of these 503s, they're all going to show the same thing, not enough water. And so what this is now telling us is over the, sorry, one more screen. Where is it? Here it is. Over the past 15 minutes, we've had, I don't know, 20 or so different orders that could not be fulfilled because we didn't have enough water in the machine. Now, how do we resolve that? I don't know. We might have create a machine that has a bigger reservoir to hold more water. We might instruct our Sumo Logic Coffee employees to check the water levels every 15 minutes instead of every 30 minutes or whatever. But this is now showing us what has gone wrong with these use cases. So what I want to do now, I want to do this together as we've been doing, but I want to look at a 502 as well as a 402. I think we'll have time to do both. So what is a 502 indicating to us? And we'll go ahead and kind of see if you can figure it out. I'm going to tap dance for a moment just to give you a second to see if you can find out what a 502 means. But remember, 503 was lack of water. So what's a 502? Well, let's pick a 502. Let's look for the red line at the lowest level. Here it's related to coffee service, not the water service. So we're going to click on the box that has the red line. Then we're going to go ahead and open those logs again. And what we should see now is the reason that this order was not fulfilled. In this case, the info was received for an order for 4 coffee grains. The machine was out of coffee grains of this amount, and so it could not fulfill the order. So what tracing is now showing us is the fact that the 502s are indicative of not enough coffee. Once again, how do we resolve that? I don't know. We purchase more coffee, we get a bigger coffee bin, whatever, but we now can start to understand that and gather this data. And then finally, I want to look at a 402. Now, when I look at a 402, I see red horizontal lines, but I don't see the red lines over the coffee portion here, the coffee machine. Everything seems okay here, which is great. What I do notice and want you to notice as well is the red line is with the pay in. So what this is telling me is there's not an error related to the coffee machine itself. It's related to the cash desk. Now, I may know what that means. I may not, but let's go ahead and figure out what that means. Very simply, I'm just going to click the pay in a box that has the red line. And then I'm going to open those logs with the span ID. And what I'm going to see here, there's a lot here, but not too much. What I see at the very bottom is an indication of what went wrong. I see payment was in progress. The individual ordered an espresso. The system is getting the product price. The system is querying the database for the price of the product. The system is calculating the total price of the espresso. And here we see the total price. So the individual ordered 2 espressos at $2 a piece, equaling $4. Well, here was the error. Very simply, the user did not have enough money in their account. Their credit card was essentially denied. And so now we know that 402s are related to not enough money in the system, or excuse me, not enough money on the individual's card. And so now we understand that. We learned that through tracing. All right, so let's go back to the slides. We're just about wrapping things up here. Let's see. So we did the hands-on exercise with tracing. Oh, the one last thing I wanted to point out is a good way to finish up. We're not going to really an exercise with this. We're running low on time, but just mentioning it is important, is the unified alerting. If you remember earlier, and I don't really expect you to, I hope you do, we looked at this observability unified platform. And so what we looked at most recently is troubleshooting using root cause, diagnosing using tracing, but another really important aspect of observability is monitoring and is getting alerts about what's going on or not going on. And so I just wanted to either remind or introduce, I'm hoping this is more of a reminder, the fact that Sumo Logic has unified alerting available within it. So within Sumo Logic, you can go ahead and create a unified alert, either for logs or metrics, and you can have these alerts trigger based on various criteria. So that the next time you can set it up so that the next time you have 10 503 errors in a 5-minute period, you can get notified. And maybe that, based on that notification, that's you send an email to all the stores reminding them, hey, keep an eye on water levels, or keep an eye on coffee levels, or whatever you do with that information. So the alerting is important. The fact that it's unified is even more important. If you've used Sumo in the past, it wasn't unified. It was actually kind of messy. You had an alert section for logs, for metrics. But now what we have is very simply, and this is not an exercise, I'll show you this very quickly. You add a monitor, and you're going to put a query, either a logs query or a metrics query, saying, when this type of data is detected, go ahead and report. So for example, if we're doing a log query, we might want it to alert us when it has, I don't know, 10 or more results within 5 minutes. If that happens with the log query we enter, we want to notify the ops or the managers or whomever. We can go ahead and do so. So like I said, wanted to point that out. It wasn't really the main feature for today, but alerts are helpful. Let's see, just to wrap it up, certainly if there's questions, go ahead and ask. There was a request to share the recording, and we will do that. I should have it out later today. Yeah, it should have it in a few hours. Let's see, summary, next steps. Kind of went over these, the challenges, the solution, the benefits. Oh, this is what I was looking for. There was a question earlier about bringing data in, and this was the help article I was looking for. More specifically, setup collection. Here it is. Sorry. So this article is going to help you bring in data into Sumo Logic, whether it's AWS data, which is what we were focusing on today, whether it's Kubernetes, etc. You would just essentially follow the steps. They're pretty straightforward, and they're documented very well. Let's see what else before we get you out of here. Last thing is just a plug for the other training that we have. Let me put this in the chat as well. What this link is going to get you to is the ability to sign up for other, like I said, other trainings, other workshops that we have, which is a great way to just become more informed about Sumo. All right, so let's go to questions about this. Let's see, another question from Doug, which is great. Do we have a link for tutorial documentation to get smarter about how to do this kind of work and build queries? Good question. The best place I would send you to is probably that link I just gave, going to the observability solution. This is really going to go over how to set up, how to integrate, how to monitor. Yeah, the link I sent is probably the best place to go. If you need more help or questions, which you may, and please do, reach out to us. You can reach us. Certainly, our support team can help with questions about that. Also, our community forum is a great place to ask questions about that. So you may have noticed, and you may have not. If you go to, if we go to home and we go to learn, there's actually a lot of different help here. There's cheat sheets, there's documentation, but community here allows you to interact with other Sumo Logic, both employees and customers, and start to talk about bringing data, doing whatever, bringing data in, as you see, sending it, ingestion, query library, just a great way to interact with others. Let's see. Good question by Mohan. The question is, do you need to obtain a subscription based on use case, or is it offered as a single observability bundle? So I'm not great with pricing and things like that. I believe it's part of a single bundle that comes with your account, but I don't want to swear to it. So I would direct you just to your account manager individual for that. I should know that stuff. I apologize, I don't, but I try to stay away from pricing and things like that. But I just don't want to answer incorrectly. So, but I believe it's included in all subscriptions now. All right. That's going to conclude our time, or yeah, pretty close to our time. So thank you for attending. I apologize that that Root Cause Explorer demo was a little bumpy. It has been before. That's not that that's an excuse, but I do apologize for that. I'm going to work on that, getting that correct. But thank you again for attending. Let's see, one more question by Mohan. Is it hosted on Sumo Logic Cloud or public cloud? Do we support hybrid cloud? So we support hybrid cloud. We support public clouds, but you will bring your data into the Sumo Logic Cloud. So your data will come from AWS, Azure, GCP, your server in the closet, and it will be brought into Sumo. And then from there, you would use the features of Sumo to start to dig into that. And the bringing that data in is that collection process. So that's going to be how to bring that data in. And we just don't cover it in this class. Just we don't have enough time. But great questions. So thank you again, everybody who joined. Hope you found this helpful. We'll send out that recording in a couple hours. So thank you again, and enjoy the rest of your day. Bye, everybody.